Good day, Doctor. We are Group 7D, and the journal article we chose is titled Toward Understanding Variations in Price and Billing in U.S. Healthcare Services.
For the introduction, price disparities was found in U.S. exist with the lack of transparency hindering consumer benefits despite of legislative efforts. For example, a same screening mammograms that cost from $129 to $694 in California. This paper examines the practice of healthcare providers overcharging for Medicare in US, which can lead to high price variation and inequities in healthcare. The analytic approach used in this paper was predictive methods. The solution buyer of this paper will be firstly policymaker, so that they can formulate more equitable and efficient healthcare pricing strategies. Next, healthcare providers, to understand how billing practice compared to others and possibly adjust them to align with industry standards and regulations. Next, consumer, to empower them to make informed decisions towards their healthcare choices.
The objective of this study is to predict a healthcare provider's access charge quartile and identify features predictive of their membership in that billing group. For predictive methods, multi-class classification models are used for 3 medical procedures with high price variation, incorporating features related to healthcare providers, medical procedures, medical practices, and patient demographics. Machine learning algorithms and feature engineering are used to analyze and classify healthcare providers into access charge quartiles. Before applying the machine learning algorithms, tenfold cross-validation approach is used to avoid overfitting and leakage of test data into the trained models to ensure model accuracy and generalizability. Then, various machine learning algorithms such as random forest, gradient boosted trees, classification and regression trees, regularized logistic regression, and deep learning are used for better out-of-sample generalizability. Lastly, Shapley additive explanation approach is used for model explainability, helping to understand feature contributions in the model predictions.
From the article that we select, we are not able to identify the specific analytic tool they use for predictive analysis, as it's only mentioned the data source that researchers use for predictive analysis, which is Healthcare Common Procedure Coding System. This is the system which contains all the fundamental information for this research, for example, access charge ratio, medical procedure performed per visit, manufacturing, and payment. However, we have done our own research and we believe that the data analysis tool they use for this article is Statistical Analysis System. The reason support our assumption is SAS is able to support a variety of modules for statistical analysis, machine learning, and data visualization, which we are able to see in this article.
The area under the ROC curve is referred to as the AUC metric, and its value ranges from 0 to 1, where 0.5 represents a random classifier and 1 represents an ideal classifier. Realistically, a classifier with an AUC value closest to 1 is more desirable. In multi-class classification, AUC is calculated for each class 1 versus O and then average weighted by the class frequency. Since classifier cannot be optimized using the AUC metric, a classification loss function such as logarithmic loss or simply log loss is used as the optimization metric that quantifies the accuracy of a classifier by penalizing false classifications. The interesting characteristic of log loss is that it gradually declines as the predictor probability improves. However, it steeply increases as the predictor probability decreases. In other words, log loss assigns a heavy penalty for a classifier that is confident, which is high predictor probability about an incorrect classification. Therefore, the lower the log loss value, the better the classifier. Based on Table 3, we can conclude that the gradient booster tree GPT model performed the best for all 3 procedures with high accuracy 73% to 86% because of a high AUC value 0.93 to 0.97 and has a least log loss value 0.43 to 0.62.
And I will be presenting the conclusion of this study. Firstly, this research is crucial for addressing inequities in healthcare service delivery. The predictive model developed that billing patterns serve as significant indicators Well, social economy and demographic factors also play important roles. Secondly, policymakers should adopt a data-driven, holistic approach to healthcare pricing decisions, considering factors beyond just the medical procedures themselves. Lastly, implementing this approach promises a fairer, more efficient healthcare system, addressing the root cause behind excessive charging practice. In conclusion, this article utilizing predictive models advocate for a transformative shift towards a fairer, more inclusive healthcare landscape.
I will be wrapping up our video presentation. In essence, this research is a call to action. It advocates for a transformative shift in healthcare pricing, a shift that promises to make healthcare more fair, inclusive, and accessible to all. This is not just a matter of numbers and data. It's about real people and their right to equitable healthcare services. Thank you for your attention. We look forward to a future where healthcare pricing reflects the value of justice and fairness.